So now you know what the problems look like. I'm gonna put it on the screen so you can follow along. The screen will be up for about 10 minutes, y'all, because what's gonna happen is Zoom has reduced everything to about 40-minute intervals. So the screen, when it pops out, fine. Just open it up in SVD and you'll be able to view it on your screen. Okay, so I'm gonna put this as current slide. And this is the problem. Now, I need you to pay attention. This is a long problem, and you're gonna do the same thing you do. So take great notes, okay? And yes, there will be a quiz, but it'll be on Thursday, because Friday you guys are not coming, right? You're going to a trip or something, I think. All right, so class is almost over with. Pay attention, pay attention, pay attention. All right, so let's get this show on the road. We need to turn to what page again? Let's grab our physics books. Let's put on our physics thinking caps. We're all, aspiring physicists real quick. 759, great job, Alika. All right. So you see it starts with parallel circuits. Who would like at least 10 points for reading, well, not 10 points, I'm sorry, 20 points for reading that paragraph here? Anybody? It's not 20, it's not 15 points, but who want to do it? Nobody wants to read? Because I'll read if no one wants to read. Page 759, that paragraph that says parallel circuits. 15 points. Yes. Y'all got it sweet. Remember, you used to have not black people up here teaching physics. Now you do. But y'all got it sweet. You gonna read, Alika? Let me turn this on for a second.
We read it in the practice problem?
No, but you're reading on page 759. It says say, and you're gonna stop at traffic. See at the bottom?
Say you're riding in a car going down a busy three-lane highway. The three lanes of the highway are interchange paths for the car to follow. Each lane has a certain resistance to the car. That is, each lane has a speed limit, and the other car is traveling in it. So your car can only go as fast. Still, each lane carries its traffic independent of the other lane. We say that the highway has three parallel lanes of traffic.
Okay. All right, stop there. That's 15 points more for you, dear. All right, I want everybody to start jotting down these notes. The first big note you're going to need to handle, this is your tool, the equation for taking three resistors in parallel, which you saw earlier, and combining them into one equivalent resistor. Okay? Similar to what we did to series, but now it's parallel, right? You saw the current change in each branch. So here's the notes on it, right? This equation is for equivalent resistance, and again, this is for parallel circuits, okay? All right, let's keep it moving. What is the equation? Well, I told you it's in the green box. It's right in the middle of page 760 with orange trim, right? So that is 1 over REQ, and this is really, really difficult if you didn't pay attention, so be ready for it. So that's 1 over REQ is equal to 1 over R1 is 1 over R2 plus 1 over R3 plus, and then dot, 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 right? That means if you have resistor 4, resistor 5, 6, you would include that 1 over factor, right? So continuing on, known and unknowns. Let's get to it. So what do we know in this problem, right? What is the problem giving us? That's what they say mathematically or as a physicist. What do I know? And then, of course, ultimately, what don't I know? What am I looking for? And I will post this recording, because I'm recording right now on Facebook. I'll download it, put it in ESI later, okay? So don't worry about it if you don't get all the notes or you don't understand something. That's why I do that, so y'all can, because I know some people have to see it again before they understand it. All right, now, looking at this problem for 5 points, oh, you gotta watch out about that. You got to install outlets. I can't do nothing about it. It's all the tables. Oh, okay. So what are some known values? Anybody want to get some points? You got to tell me what's inside of the known section.
E equals 37.9.
E, he got it right. Electromotive force, and that's your epsilon. He said E. It's the Greek letter epsilon. And it is, and that's 5 points, Carson, pretty good. So he said it's going to be, where's that voltage at? 25.77. And you know it's volts, right? So that's how you use it was epsilon. What else are we given? There's points out there if you can tell me what else goes in the known section. Type of data, that's not in the known section.
What he named already?
He already did our electromotive force, volts.
The vote.
He already gave me the volts. So what else is there? Huh?
R1.
Ah, I thought it was obvious. Okay, R1, 5 points, but what is it though?
277.
Say that number right, girl. Okay, yeah, 277 point what?
84 ohms.
Thank you. And omega is what you use here. It's the Greek letter. You should be comfortable finding the symbol. I do take off points if I don't see it. Don't be trying to cut corners with me. I don't take sloppy work. That's 5 points for Lika. Who else? What else do we have here?
R2.
Very good. Which is?
100.77.89.
Wait, 100 what?
I mean, what? 177.
There you go. I know that's not what I typed up in that problem. 100 point.
I'm sorry, because I'm trying to type and say it.
Yeah, it's okay. Okay.
R3.
Oh, 5 more points. Okay. 377, you say? And 0.46 omega. Anything else do we have in the knowns? I don't think so.
No.
So what are we looking for in the unknowns?
V3.
V3, not exactly.
Not.
So take a look. It's a little different. Page 761 if you're confused about what I'm doing. I see a few books open. Ah, she got it. That's part A, right? So remember, it's asking for current now because we saw in the circuit the current changes in each branch. This is me reinforcing what you saw in the math. So I is total current. You can say I total if you want, because they combine like Voltron and make a total current. What else you have? You have part B, and there's a few values here to go here. What are they? That's 5 points, Alika, again. I'm keeping track. I think you got what? 5, 10, 15, 20 points. Pretty good. What goes here? So you tell me what they all are. I1.
I2, I3.
Thank you. All right. 5 more points from this. And that's only 5 because you said that. That was like all one answer, girl. So try to multiply your 5 points. So this is the branch 1, resistor 1. You're going to find that like we found earlier. This is in amps. We have I2. This is a 1. Some number, we're going to calculate. And I3, some number, and it's an amp. So all these will be the current that we saw in those different branches, right? And then don't forget, somewhere along the lines, we're definitely going to need to use pretty much the electromotive force version of Ohm's law. If you don't remember that, you're going to use this again. Remember I said V equals IR? Well, the other way to write it is also electromotive force is equal to the current multiplied by the resistance. Okay? And it depends on which resistor you're dealing with. So this over here is just, you're going to need it later. It's still Ohm's law. There's 2 versions of it. Or. Okay, so we got everything we need to cook this problem, and it's a lengthy problem. So let's get started because right now it's 12:43. I want to make sure you have more than enough to take care of the you do on your own, and make sure you turn it in by tomorrow. All right, so where do we go with this? Well, first things first, we got to find out what the equivalent resistance is, and this is a long math problem. So pay attention. You're gonna do something weird with the fraction before you move on. All right, so what am I starting with? Well, let's use this equation. You're going to solve. This is step 1. So call this step A because this is going to give you everything for part A. Solve for your REQ. All right. Remember, REQ not one of REQ. You're going to see why it's tricky. You use this equation. We have 3 resistors, so we just rewrite it with those numbers. First, let's rewrite the equation. So that's 1 over our REQ equals 1 over R1.
I got the wrong problem.
What do you mean?
I got the wrong problem.
I don't know how you got the wrong problem. All right, so we're going to put the numbers in now. So that's 1 over REQ still. And this step you do in the calculator, please. try to get the notes you best can, Carson, and you'll be able to do it later. Okay, because these steps are going to be important. So, with that said, this is 1 over, what was our R1? Let's look over here. That is over 277.84 omega, moving on, plus what? 1 over, what was the next number? R2 was, just follow this equation, y'all. That's 177.86 omega, and plus, I'm just going to bring this down, but that means it continues as a string of calculations, right? So that's going to be 1 over R 377, around over there, 46 omega. All right, let's put this all in the calculator, and don't think you're done with it because we got to reverse it. We're going to do something called the inverse of a problem. So if we grab the calculator, I'm going to show you how to type this in because it might be difficult for some. All right, now, you hit the fraction button. You're going to be hitting the fraction button 3 times, right? So the first time I'm going to hit the fraction button. It gives me the option to make a fraction. Everybody see this? So I hit the fraction button, I plug it in. It's 1 top, press down, and then you have, what was the number? 277.84. Come over here, plus. And then, you know you guys are recording, so y'all need to stop using profanity. Then we got 177.86. And I'm gonna pass the calculator around so y'all can see how I did that, so you'll be able to do it on your own. Plus 1246, I'm doing okay on time. We got a little time to work on other stuff. Plus the fraction again. 1 come down, 377.46. All right, hit enter. I get 0.012. Right? And we're not done with it because that's 1 over REQ. So it's not correct, almost correct. We need REQ, not 1 over. So let's write down what it is, and I'll show you how to get REQ. So that is simply 0.01. We'll put it 1871 omega, and this is like -1. Because it's not exact. Now, how do I get exactly REQ? This is not REQ. This is 1 over REQ. That's why I got next to the raised to the -1 power.
You're going to put this on the line, right?
You need a recorder? Yeah. I'm recording now. So try to get as much notes as you can. Stop stressing, man. You can do it. All right. So how do I change this? Well, it's real simple. Don't pay attention because you're going to do this on your own, and then you do. Well, when you do it like this, as I put all these fractions together, you got to do what's called raise it to the -1 power. And it'll flip this 1 over REQ to just REQ. All right? I hope that's important to you and remember. Because in SAT, ACT, them tests really do that to you. So we're going to take this and we're going to say, hey, this entire thing here, raise it to the negative power. So to get REQ, we simply take this number, put parentheses around it, say 0.011871 omega, raised to the -1, and come on the outside and do just that. We can leave this on the outside because we don't want to do that. This is just going to be omega once we do that. Okay? What are you doing? RSU. Leave it there because these will cancel. All right, now, what do we got? Let's open up the calculator. I'll take the same answer and I can just literally raise it to the -1 power. So I'm going to take this number, highlight it, enter, and then we'll hit the little caret feature, put -1. That yields, this is all I did, everybody. I'm going to pass the calculator around once I get this. It's 84.24 ohms. So the new value is going to be REQ is officially 84.24 omega. Okay?
I text you my hours.
You did? You mean you SD them or you, what do you do? I'll look them up. You don't? Huh? All right. I'll try to tally your point, your hours up and we'll talk. You gonna be here tomorrow for work?
Yeah.
Okay.
Yeah, Friday.
Yeah, I bet. You want to get all the money you can. All right, so let me keep going because it's 12:49 and we're almost ready for part B. That was almost to total amps, but once we find that, then we can break up the amps and find other things. So how do we find the total current now, right? Well, to find total current, we have to use REQ. We got REQ. Now we can use that equation before. Remember, another version of this equation up here is epsilon is equal to REQ multiplied by your I. So you can use that as well, and we're going to. So let's do that. All right, we're not done. We're still on part A. We got to find I now. So I said again, now solve for I total, which is the beginning of the parallel circuit. To do that, use epsilon is equal to REQ, which we just found, multiplied by I. We got to do a little bit of algebra to get I isolated. So let's rearrange this, right? How do we do that? Well, we got REQ multiplied by I. The opposite of multiply is divide, right? So let's write it again. So epsilon is equal to REQ multiplied by I. I won't get too close, we got to do something to it. And use a different color here. Going to divide by what we don't want, which is REQ next to our current. Which do to one side, you ultimately have to do to the other. Cross out the REQs, rewrite your equation. So we end up with I is equal to epsilon over REQ. All right, now we're ready to plug the numbers in, okay? Because I set it up to get REQ by itself, I by itself. So that is what? Well, there's going to be I is equal to, let's plug in our numbers. We know our electromotive force is 25.77 volts, right? And then what was our REQ? Well, we calculated that over here, and that's 84.24 ohms. That gives us a yield of what? I'm going to get 10 points if they got it. If not, y'all deaf. Y'all okay? Carson disappeared in the bathroom. Uh-oh. So, anybody got it or should I calculate it? Y'all just typing, huh? The video will be available tonight. Let it just breathe. Get as much as you can. So that is a yield of 25.77 divided by 84.24. I get 0.306 amps. 0.306. Okay, I'm gonna box that. That is the end of part A. Let's finish part B. What are you doing to that, man?
No, somebody had on the floor like
That's mine. Just put it down.
Oh, no, I was just taking this off for you so you can make a whole brand new.
I didn't want to make it fresh one. I wanted to put it back up.
All right.
That was a lot of work. Talk about it, this was tearing apart. Just put it on the table over there. I'll put it back up later. What was I saying? So let's do this. This is part B, the final part, like the final boss. So solve for the individual currents, right? So solve for your I1, I2, and don't forget I3. There's 3 resistors. Okay? Now that we have that into play, all we got to do is what? Well, we come over here and remember, we have Ohm's law we can use like this. So that's electromotive force. The current is the total current, and we just break down each resistor. So let's do that, right? We know the equation for it is this, so we got to rewrite it for each current. Okay, so let's do that. And that'll be electromotive force is equal to I. This is for your first drop, right? So let's say I1, right, times R1, right? You see what I'm doing? So we're trying to find the individual currents. This is the total current around the circuit before it breaks off into branches. So what is that? Well, if we rearrange it for I1, that just simply, we don't have a lot of space here, so I'm just going to do the algebra real fast for you. So I'm going to rewrite it. All right, and then I'm going to do some algebra on it. So this is divide, right? Multiply, so divide is the opposite. All right? These cancel. Your new iteration or new step is what? Just rewrite it. So that's going to be I1 is equivalent to epsilon over R1. Plug in the numbers. You can do this for I2, I3, all the way down. So what does that become? Well, it looks like it's I1 is equal to, our voltage was this. Okay, and our resistor, our what was that? All right, so what does that yield? Well, let's take a look. Down some. Calculator. And it's 12:54. So I'm gonna stop here. You guys are responsible for I2 and I3. Just redo what I did. So that's 25.77. Because I want y'all to get ready to try to work on your exit slip. The video will be available. Remember, you still have I2 and I3 to do. Just use R2 and R3 for that calculation. But I did this one. And then you still got to go back and finish your you do on your own. Okay, plus the exit slip. Turn everything into PDF. Only Ashley can send me a message. Everybody else has to send it in the assignment for that day. Okay. You got it? Let me see what your calculator said, girl. Okay. No, bro, I can't do that. It's called prescription glasses. You tripping. All right, 0.093. I think there's a 7 behind that, too. So 0.093, right, Alika? And that's amps. That's 10 points for Alika. You want to do one more before I stop the video and stuff? Okay. So we only got 5 minutes class left, y'all. And again, check XB Messenger, and in the class, I will post this video today, okay? So you can go back and review it. Kind of like summer school when I was doing the videos. I did videos because I know when I was in college, I did not like having to keep up with my professor. So to skip a lot of steps, I'm going to rewrite this as I1, I2 is equal to, I'm not going to do the algebra again, epsilon over R2. Well, what does that translate to? I2 is equal to, we know the same voltage, 25.77 volts, divided by, what was our R2? It was 177.86 omega. Alika, did you want to get another 10? Show me the calculator, sweetheart. She already got it. She know how this game goes. All right, so we got very good, girl. 0.145, I want to say. 0.145 amps. And don't forget at the end, you still have to complete, because these are sections of Part B. You have to still figure out what I3 is. I'm going to write the equation. Y'all are going to finish it out. So R3 is what you use for this one. Plug in the values and figure out what I3 is on your own. Again, don't forget to try to finish the you do on your own. Same problem, change the numbers. God, let me see what you did, girl. Because the voltage doesn't change. So 377.46, you got it. Another 10 points, okay. You rocking out. So 0.068, that's a 2. 0, she figured it out for you all, so don't have to worry about it. But you have to write the values in, so maybe you do that real quick, because I didn't know she was going to do it that fast. This is 25 point, is not box, but she gave you an answer. You can tell me that answer again, Lee, because I'm just writing it out for y'all. I know y'all got a lot to do, so one minute. Now, yeah, babe, 1 second. I'm trying to write this step out. And we about to get ready to go. Who is that behind you? Oh, that's Angelique.
Yep.
You can put him back in the tank, because I'm about to get him ready to go back home with me.
Yeah, he's so tiny. Oh my God.
He's not going to be that way by next month. He's going to be bigger. He gets big as the other one.
He's smaller than City.
Well, yeah, because I started him out different. I think she picked him up for somebody else. So what was that answer again, Alika? Because we're almost out of time. We got 2 minutes from leave. 0. What? 0.068. Okay. And that's amps, right? All right, all done, everybody. Get all these steps. The recording will be available later, okay? Watch it at your leisure, but do get it done. You have until Thursday to finish all the stuff we've done, and get ready to leave. It's 12:58. Yep. See, there she goes. She's saying line up. All right, let me stop this because we're out of time. This is for the other students. 24 minutes. I didn't do that bad.